welcome back. So in the last lecture video we had expression for the four shape functions. So today we are going to find out all the coefficients first. Okay, so the first, for n1 we had the equation which looked like 1 0 0 0 0 1 0 0. Then we had 1 L square L cube, then we had 0 1 2L 3L square multiplied by we had alpha 1 beta 1 gamma 1 delta 1, and everything was equal to 1 0 0 0. Okay, so in order to solve this one, if you look at just first one, the first two equations, what you get alpha 1 equal to 1 and beta 1 is equal to 0. Okay, so if we put those values here, then what we will get here is we will have this we are going to turn this into 2 by 2 equations only now. So we will have L square L cube, then 2L, then 3L square, and then multiplied by we'll have gamma 1 delta 1, because only these two are now unknown, and equal to, so we have here 0 0, so we write 0 0, and then minus will be simply we are looking at the last two equations with alpha 1 equal to 1, beta 1 equal to 0. So we multiply here 1 0 1 0. Okay, so here this is 1 0, so we get 1 only, so we get this we get 1, and this is 1 0, here 0 1, so multiply 0 times 1 and 1 times 0, so becomes 0 only. So what we get is like this. So simply, or what we get is this. So we can also take L as a common, so we get L square 2 3L, okay, multiplied by gamma 1 delta 1 is equal to minus 1 0. Okay, so we can find out now gamma 1 delta 1 is equal to 1 over L, and then the inverse of that actually we want to find out, so will be equal to here 3L square minus 2L square, so becomes L square is a determinant, and then we will have interchange this and this, so we get 3L and L here, and this becomes minus, so minus L square and minus 2 and multiplied by minus 1 0. Okay, so simply we get 1 over L 1 over L cube here, yeah, and here we will get simply minus 1 we multiply by minus 1 here, and so what do we get? We get 3 minus 0 here, so minus 3L, and in this case we get 2, so minus 3L 0, then here we get minus minus plus 2. Okay, so simply we are getting 1 over L cube and then minus 3L 2 only. Okay, exactly the same thing what we wrote. Okay, so that really means our n1 we know now, n1 we can write it as n1 x equal to alpha 1 is 1 plus beta 1 is 0, so we write we write nothing there. Then we have gamma 1. So, gamma 1 is minus 3L over L cube. Okay. So, minus 3L over L cube times this becomes x square, and then we have plus 1 over L cube times 2 over L cube is the delta 1 times x cube. So, or n1 x equal to 1 minus 3 over L square times x square plus 2 over L cube x cube. So, we get n1 like this one. Similarly, you can find out n2 and n the other values as well. Yeah. So, for n2 we have to write these equations. So, what equations we have? So, we will have 1 let's write on the next page, so that we will have the values available with us. So, in order to find out n2, what we will need is the original equation. So, this becomes 1 0 0 0, then we have 0 1 0 0, then we have 1 L L square L cube, and then we will have 0 1 2 L and 3 L square multiplied by, here we will have alpha 2, beta 2, gamma 2, delta 2, okay, and that is equal to, and here we will have 0 1 0 0. This is the same equation we derived last time. So, this is we are going to find out n2 in this basis. Okay. So, here what we get, the first two rows will give you alpha 2 equal to 0 and beta 2 equal to 1. Similarly, we will put these values here and find out. So, what we get? We get L square L cube, then 2L 3L square multiplied by gamma 2, then delta 2 is equal to 0 0, and then we have 0 and 1 here. So, multiplied by 0 and 1, so becomes L, and 0 in 1. So, this becomes 1. Yeah. So, basically that side we have to take L and 1. So, minus L and 1 like this. Yeah. So, what we are doing? We are writing the last two rows only. Yeah, but I have taken all the known on the right side. Yeah, that is what we did. That's it. Okay. So, how to solve it? We can solve it now. Gamma 2 delta 2 is equal to becomes this one. So, 1 over L, and then L L square, and then we already have the inversion for that. So, we will just use this one. So, just a minute. So, 3 L, yeah, and then inverse of that and multiplied by L1, okay, equal to. So, from the last page, let's write down the inverse of that. So, inverse of that is 1 over L square, then 3L minus L square minus 2L. Okay. So, that is what we will write. Okay. Or this is also easy actually. So, actually you can invert right here also. So, 1 over L in inverse of this one is 1 over L square, and then simply you interchange here. So, becomes 3L minus L square minus 2 minus 2 and L here. Yeah. So, and multiplied by L and 1. Okay. Okay. So, what we get? 1 over L cube and then we multiplied here, so we get 3L square minus L square, so 2L square, and here we get minus 2L plus L, so minus L. Okay, so simply we get equal to 2 over L and minus 1 over L square. Okay, so 2 over L and minus 1 over L square. So that is what? That is gamma 2 and delta 2, and because of that we can write now N2 x in that term. So will be equal to 0, so we are not writing here. Then x, beta 1, beta 2 is 1, so write x plus 2 over L x, 2 over L x square minus 1 over L square x cube. So N2 we have determined already. Okay, now we have to find out N3. Okay, so in order to find out N3, we have to write the equation. And what is the equation? Same as earlier, this matrix. So we have 1 0 0 0 0 1 0 0, then we have 1 L square L cube 0 1 2 L 3 L square, and we multiply it by alpha 3 beta 3 gamma 3 delta 3. Okay, and here you have 0 0 1 0. Okay, okay, so just note here this both 0 0, so that really means we actually don't have to subtract on the right side, okay, as we have done here, right? Because this really means that alpha 3 is equal to 0, beta 3 equal to 0, first of all. Yeah, so we write here alpha 3 equal to 0 and beta 3 equal to 0, and rest the equation that we have to solve becomes simply L square L cube 2L 3L square multiplied by gamma 3 and delta 3 is equal to 1 0. Okay, that really means gamma 3 delta 3 is equal to 1 over L. We are taking out L common, and rest is, this will be 1 over L cube. So let's write like that to begin with. So 1 over L cube, then 3L. So I'm copying from the this side. So we have 1 over L cube and 3L minus L square minus 2L. Okay, and multiplied by multiplied by 1 0. Okay, okay, so we get the value 1 over L cube, and then we have 1 0, so 3L, and this is 0. Okay, so minus 2, sorry, this is minus 2. Okay, 3L minus 2. So that becomes simply 3 over L square and minus 2 over L cube. Okay, and hence N 3 x we can write it as, so we have alpha 3 0 beta 3 0, so both 0. So then we have gamma gamma 3 delta 3 is equal to this. So gamma 3 is 3 over L square x square minus 2 over L cube x cube is our N3. Okay. Now N4, in order to find out, we have to write the equation again. So this becomes 1 0 0 0, then 0 0 1 0 0, then 1 L L square L cube, then 0 1 2 L 3 L square. Okay, and multiply it with alpha 4, beta 4, gamma 4, delta 4, and everything has to be equal to here 0 0 0 1. Okay. Yeah. Again you can notice here the first equation will give you alpha 4 equal to 0 and beta 4 equal to 0, and the equation will simply be L square L cube and 2L 3L square gamma 4 delta 4 is equal to 0 1, and simply we get gamma 4 delta 4 is equal to 1 over L cube. Okay, and then we are just copying from here 1 over L cube, then 3L minus L square minus 2 and L. Okay. Okay. So and then we have 0 1, and hence we get that is equal to 1 over L cube, and multiply it with 0 1 minus L square and then L. Okay. So what do we get? Finally is minus 1 over L and 1 over L square. Okay. So this is what? This is gamma 4 delta 4, and therefore so thus we get N4 as a function of x is equal to we have alpha 4 and beta 4 equal to 0. So we will straight away start with gamma 4 is minus 1 over L x square plus 1 over L square x cube. Okay. So this we have all the shape functions. Next is to use them to find out the stiffness matrix, and that's what we will do. So we will have to start with the weak function. So that's what we will do next. So what is the weak function? So weak function is, so if you recall from the last time, so we have integral of w q dx. So integrated over 0 to L plus we have 0 to L integration d square w dx square, then ei d square u over dx square dx. Okay, then we have all the boundary conditions. So plus we have ul, okay, then vl minus u0 v0, then we have minus theta l times moment m at L plus theta 0 and m 0, that is equal to equal to 0. Okay, this is a plus here. Now we will do the usual stuff. So we will assume u x as a function of, as we have defined already, ni di. Okay, so I equal to 1 to 4, and w also of the same form. So we'll write like I equal to 1 to 4, and then we have n, let's we call it n I. Okay, and let's call this one is as c ci, like this. Okay, okay, so where di already we have defined, so where di, or we write d1 is equal to u 0, d2 equal to du over dx, x equal to 0, d3 equal to u l, and d4 equal to du over dx at x equal to l. Similarly, our u is also have the exactly the same kind of behavior. So we write c1 is equal to w0, c2 equal to dw over dx as equal to 0, then c3 is equal to w at l, and c4 is equal to dw over dx at x equal to l. Yeah, okay. If that, and all these values are, as you know, that w is arbitrary, hence these coefficients are also arbitrary basically. Yeah, so we are, although we are defining ni, that also because w could be any function. Okay, so this coefficient can also be any function. So they this coefficient can also be any values. Okay, so that property we will utilize later on. Let us now we assume that this is the value c1, c2, c3, c4, like this. Okay, so next thing is to put these values into this, the weak function, the weak form of that, and let's do one by one. So we have first term is w times q. So we have w which is equal to this one. Okay, so which is it comes 1 to 4, and then ni ci. Okay, so write nix just to know in this is a shape function which is a function of x. Okay, then ci. Okay, then q dx 0 to l. Okay, then second term is this one, so let's write that also here. So plus 0 to l, and first in terms of w, so we write d square w. So it will be simply summation of second integral differential of ni, right? So we write summation d square ni dx square ci, I equal to 1 to 4. Then we have ei, so ei. Then we have d square u dx square, and u is given by this. Yeah, again this is second differential, so we take second differential here. So what we will get is like this. So I equal to 1 to 4 then d square n, let's call it j here, okay, so that both of them don't mix up. So j equal to 1 to 4 d square n, okay, j d x square, and then we have dj, and here we should have dx. Okay, so this we have completed. Now all these things will be there, so we just write as it is. So plus we have ul vl minus u0 v0 minus theta l. So looks like we made some mistake in the last lecture video. Here the weak form should not have u term here, so it should have w term. So as you know, we have w term here also should be w. We should not have theta term, rather we should have dw over dx term, okay, at x equal to L, and here also we will should have dw over dx term at x equal to 0. Okay, so you have to accordingly. So let me see. So wherever we derived in the last lecture video, so we had dw over dx term, w term, dw over dx term, all of them. Here also dw we had, and then suddenly I wrote instead of w, I wrote u, so that's why this is the problem. So he should have been dw here on page 14.4. okay, so dw here it should be, yeah, so all these are correct, but only wl is here. Same thing here, say dw over dx. So here we should write, instead of this we should write dw over dx at x equal to L, and here it, instead of this we should write dw over dx at x equal to 0. okay, so I will write x equal to 0. okay, so this correction I made here, but please do this correction in your notes. okay, so now coming back, so this correction we have done here. So instead of writing u, we have to correct it to w in all the terms here. okay, so accordingly we have to do here. So this would be wl, and here also wl. So here instead of theta we will write dw over dx at x equal to L. okay, so this is equivalent to theta though, and then this will be m at L, and plus dw over dx and x equal to 0, and these all things will be equal to 0. Note here that wl is C3, then w0 is C1, dw dx at x equal to 0 is C2, and this is C4. So all those values we can put it here actually. Yeah. So okay. So next thing, we will write the same thing. Yeah, but we will take C at 1 side of that. Okay, so what we will write here is we will make this common. So we write C1, C2, C3, C4. Okay, so it's common, and everything we write. So C1, C2, C3, C4, let that be a one matrix. Okay, then what do we get here? Then we will get integral, and there will be a matrix. Okay, so which matrix? There will be a K matrix actually. Okay, so I will, instead of writing like this, we say this is a K matrix. Okay, so it's a K matrix like this. Okay, and then there will be D1, D2, D3, D4. Okay, so this will have both terms, C1 terms and C term and D term. As we can see, we are looking at the second one. Okay, the second expression. We can see that the here what it has is Ci term and Dj term. Okay, so that means there are 4 times 4, 16 combinations. Okay, and that really means this, the whole thing, including the integral, can we write like this one. We will come to know what the K is. So K will have the 4 by 4 members, say total 16 members. So this K, like this one, will have. Okay, then plus we also have this term. So look at this. Okay, so from here also we are taking, we will take Ci part outside as it is here. So what remains here will be let's call the F Q matrix. Okay, so let's give FQ. Okay, this is because it has Q in it. So let's call it F, a small f. Let's call a small FQ vector. Okay, so we have that. So again, this times this times this will be a scalar. So if this is 1 by 4, this has to be 4 by 1. Okay, and then we have all these as well. Okay, so here what we see is this has all those C1, C2, C3, those as well. Okay, but for the time being, we don't, let's not write, let's expand this further. So WL, we call it now C3 and so on. Okay, so we write plus C3 VL minus W0. So W0 is nothing but C1. So write C1 V0. Okay, minus dW dx x equal to L is nothing but C4. So we write C4. So C4 ML and plus dW over dx at x equal to 0, which is C2. So we write C2 M at 0 and everything equal to 0. So looking at it, we can also actually write this such a way that we still have this in common. So let's write it again, is equal to C1, C2, C3, C4. Okay, and now we are going to write here K, then D1, D2, D3, D4 plus, okay, so here we have F2. Let's have tilde here, meaning that this is a vector. FQ, sorry, this is not F2 but FQ, and plus there is a vector here which will be, so C1 multiplies by this one, so write minus V0. Then we have C2 with M0, okay, so write M0. C3 with VL, so write VL, and C4 with minus ML, minus ML. Okay, so that everything that's equal to 0. Okay, now remember that we say W is arbitrary, hence the coefficients C1, C2, C3, C4 is also arbitrary. That really means, that tells us that K times D1, D2, D3, D4 is plus FQ plus minus V0, V0, M0, VL and minus ML, this all equal to 0, 0, 0, 0. Okay, this is a force, this also has a force. Okay, so actually moment in general term you can also M is also a kind of force only. So we have K times U, okay, equal to we will have in this form. Let's write is equal to K, let's call U equal to F, generalized form. Okay, we'll write where K equal to what, U equal to what, and so on we are going to write, but this is a general form we got. Yeah, so here this is K, U equal to D1, D2, D3, D4 and F equal to minus FQ minus this. Yeah, that will be F. Okay, so let's go one by one. Okay, so we write where K equal to, right. Okay, so where K equal to, there will be 4 by 4, so it will be K11, K12, K13, K14 and it will be symmetric matrix and so on. Yeah, so since this is symmetric, just I am writing only the terms we need to calculate. So this becomes 2, 2, 2, 3, K24, K33, K34 and K44. So we have to find out these 10 okay entries, and since this is symmetric, K is symmetric, so we can find out the others as well. Yeah, so where generalized form where Kij, okay, Kij. Now we can now look at these equations here. So Kij, when you have, so I from here, J from here, okay, and then we have Ei term here. So simply Kij equal to 0 to L d square Ni dx square Ei d square Nj over dx square, that's it, integrated over the whole x. Yeah? So let's see. So what do we have to, we have to write here Kij equal to d square Ni I over dx square ei d square nj over dx square dx 0 to L. This is what the stiffness matrix Kij will be. Okay. Notice that is exactly the same as what you derived of the same format as what you derived for the 1D bar element, but there is a difference. Instead of a you have I here, or instead of single derivative you have a double derivatives here, otherwise it is the same. Okay. Next is u. So the u, as I say, it is d1, d2, d3, d4. However, we know from the previous video lecture that d1 is equal to u at x equal to 0, d2 is theta at u equal to 0, and d3 is u at L, and d4 is theta at L. Okay, so this is u. Okay, so ku equal to f, and f is equal to two terms. Okay, so one is, look at here, so we have minus fq and this term as well. So just let's write this only, and then we will see. Okay, so this equal to f minus f q, and then minus and others are the first is v0. Okay, so v0 sorry, it's minus v0, and then m naught, so minus v0, then we have m naught. Okay, okay, so minus v0 plus m naught plus vl. Okay, so we have vl, then minus ml. So like that. Okay, of course, what is the expression for this one? fq. What is that? So fq, as you see here, this comes from this term, and comes from this term. Okay, so this will be simply 0 to L nixq. Okay, so this will have 4 terms, so just write fq1, fq2, fq3, fq4. Okay, where again, where fqi equal to 0 to L integrated, then you have q nix dx. Okay, so this is similar to what we did in the we had in the truss element or the 1D bar element, where we had f. In order to find out the force component, we just had w here, w, or not w, we call it b, the body force. So b times nix, yeah, and where nix is the shape function, it is the of the same form. So you get here. So this is what this one is. Yeah. So everything we know now. In, for example, we know fqi equal to, q is known, q will be given because this is the loading. Yeah, this is a distributed load. Ni we know already, expression for that we have. So fqi is known. So fq1, fq2, fq3, fq4 are known accordingly, right? Okay, because all n1, n2, n3, n4 are known. Now here V0 means shear force at x equal to 0, bending moment at 0, shear force at x equal to L, bending moment at x equal to L. Either they are given or are to be determined. If it's given, you put those values. If are to be determined, just leave it there, and we have to find it out what the value is. Yeah, and U has d1, d2, d3, d4, which is actually u1 theta 1, u2 theta 2. So you can also write like this also, u1 theta 1, u2 theta 2. That's also we can write. Yeah, if the beam has 2 points 1 and 2, so u1 is the vertical deflection at node 1 and theta 1 is the slope of the beam at node 1. Similarly, u2 and theta 2. So you can also write like this one. Okay, so u is known, kij is the stiffness, the component kij, the ith row, jth column, and the expression is like this one, J2L d square ni dx square ei d square ng over dx square. Yeah, so this also, since we know the shape functions ni's, so we can also find out the k values. So only thing is now to solve the problem. Basically everything is known now, and this matrix you can find out using the equation given here. Okay, so for example, let's do one of these. Okay, so let's find out k11 to begin with. Okay, so for that we need the value of n1, and based on that we can find out. Yeah, so n1 x, just we write k11 equal to what, and for that we have to write here. So k11 becomes equal to 0 to L, and we have d square n1 dx square and ei d square n1 dx square and dx. Okay, so what is n1? So let's write n1 as a function of x equal to what. So this we work today, so let's look at it. So n1 is here, so 1 minus 3 x square over L square plus 2, so 1 minus 3, so right, so 1 minus 3 over L square x square plus 2 over L cube x cube. Okay, so once we have that, we find out d square n over dx square, which will be equal to, here let's do just dn over dx only, and what we get is 0 minus 6x over L square, okay, and then plus 6x square over L cube. Okay, okay, the next is d square n1 dx square equal to minus 6 over L square plus 12x over L cube. Okay, so if I find out k11, so it will be 0 to L, then ei, we will assume ei to be constant, and then d square n1 dx square square, okay, dx square, because both the same thing multiplied, so equal to 0, integrate over the whole domain. and 0 to L, and then we have this minus 6 over L square plus 12x over L cube square dx. We put ei outside the integral. Remember that if I were variable, then you have to integrate along with this. Okay, if I were a function of x, then you put it here only, you cannot take that out. Similarly, if e were a function of x, you will keep it inside the integration only. Yeah? So here the we can state away we can write ei, and this is will be the if it is a square, so we can make it cube. So 6 minus 6 over L square plus 12x over L cube and power 3. Okay, and will be divided by 12 over L cube. Okay, so the and 3 as well. Okay, so assuming this to be some function y, so this becomes this to power 3 divided by 3 and divided by 12 over L cube. So it's like this one, and has to be evaluated from L to 0. Okay, so equal to ei, right? Then let's take this outside. Okay, so what we get is L cube over 36. So L cube over 36 here. Okay, and then we have this term. Put L here, so we get minus 6 over L square plus 12 over L square. Okay, fine. And then 0 term. So if you put 0 here, then what we have? Okay, remember we also have to cube it. Okay, so this is cube of it. Yeah, and then minus, then put a 0 here, and then we have minus 6 over L square cube of it. Yeah, so that is equal to ei L cube over 36, and then here we get 6L square only, so we get 6L square cube of it. Okay, and then minus this becomes plus 6 over L cube. So finally we get equal to ei L cube over 36 multiplied by 2 times this one, so 2 times 6 to power 3 and L to power 6. Okay, so what do we get? We get this is 6 square, so we get 6 here, so we get 12 ei 12 ei, and then L cube, and here L6 over L cube. Okay, so what we get? Simply K11 equal to 12 ei over L cube. Okay, so this we got. Okay. Similarly, you can find out K12, K13 and so on. Okay, so this is just one example.